This video is going to cover compound inequalities. There's your learning target if you'd like to pause and read it. So first of all, compound inequalities, we need to define them. These are two or more inequalities graphed together on the same number line. Okay, so two or more inequalities graphed together on the same number line. So when we look at some examples, it'll make more sense. There are two types of compound inequalities. The first type we're going to talk about is OR. So do you see how on this graph, on this number line, the value can either be here or here, but it would be impossible for it to be in both places. Okay, so that's what these are called, an OR inequality. They have this gap between the two. And the way that we write this as an inequality is x is less than or equal to negative 4. Okay, that's this part right here. That means less than or equal to that, the closed dot means it can be equal to. This arrow means that it's less than. So less than or equal to negative 4, or x is greater than, but not equal to, because that's an open circle, greater than positive 1. Okay, that is how the inequality looks for the graph they've given us. Then in interval notation, we're going to kind of do the same thing I told you before about reading your graph from left to right. Okay, so the leftmost thing on your graph is this arrow. And arrows mean infinity. That one points to the left, so it's negative infinity with a parentheses. Then it goes on until we get to this dot. And that dot is at negative 4. And it gets a bracket because it's a closed dot. Now, we have this gap. The way we represent that gap in our interval notation is with a capital letter U, but you don't make the stick on it, okay? So it's a U shape, but you don't make the little stick, okay? Anyway, that means in union with, okay? In union with. And then we start our next interval. So that is an open dot, meaning a parenthesis, at positive 1. And then it goes all the way to an arrow, meaning positive infinity, which gets a parentheses. Okay, so this is what an OR inequality looks like. Here's your graph, here's your inequality, and here's interval notation. All right, let's look at some examples. To solve OR inequalities, we solve each part and then graph it on a number line to show the solutions. So it says OR. So we've got two different inequalities to solve, this one and this one. So let's get started. 3x plus 4 is less than or equal to 10. Subtract 4 from both sides, and we'll get 3x is less than or equal to 6. Divide both sides by 3, and we get x is less than or equal to 2. So that's part of our inequality. Then we're going to go over here to the other one and solve it, and we get x is greater than 9. Okay, so this is an OR inequality. So here is what we're trying to graph. x is less than or equal to 2, or x is greater than 9. So let's just take these as completely separate things and graph them. So x is less than or equal to 2. Less than or equal to gets a solid circle, a filled in circle, and less than is going to go towards the left. Okay? Or x is greater than 9. Greater than gets an open circle, and then all the way to the right. Okay, so here is our gap. So let's write that in interval notation now. Remember, we look at our graph from left to right to do interval notation. The leftmost thing is this arrow, so we're at negative infinity. Infinity always gets parentheses. The next point that we stop at is at 2, and it's a filled in circle, so we get a bracket. Then we have our gap, so that means we have to do the union symbol. We have an open circle, so that's parentheses, at the number 9. And then we have our arrow to positive infinity. Okay, let's look at the next one. So we solve each one individually first. Subtract 8 from both sides. Negative 3y is less than or equal to negative 15. Divide both sides by negative 3, and don't forget, when we divide by a negative, we have to flip our sign, our inequality symbol. Geez, I couldn't think of it. So we'll get positive y is greater than or equal to positive 5. So that's part of our answer. And then over here, add 3, 10y is less than or equal to negative 30. Divide both sides by 10, and we get y is less than or equal to negative 3. So here, I think I accidentally stopped recording. This is an or inequality. So we have our two parts with the word or. And now we're going to graph those. So first we have y is greater than or equal to 5. So greater than or equal to gets a closed dot. And these are kind of like full number lines. I feel like they're hard to see. So I'm going to actually make my dot above it so that you can just tell better where it's at. Okay, greater than or equal to 5. So from 5, it's going to go in the positive direction with an arrow on the end because all numbers greater than 5 are included. Second part is y is less than or equal to negative 3. So here's negative 3, and it's less than or equal to, so our arrow points to the left. Okay, then we're going to write our interval notation, and we're going to go left to right. The left end is an arrow, so we have parenthesis, negative infinity. Then we have a closed dot at negative 3, so we get a bracket. Then we have our gap. That means we have to have a union symbol. We have another closed dot at 5, and then we have an arrow toward positive infinity. Let's look at one more or inequality. So we're going to distribute, and we'll get 15 minus 6k is less than negative 12. Subtract 15 from both sides, and we get negative 6k is less than negative 27. Let me make sure I did that math right. Yes. Sorry. Then we're going to divide both sides by negative 6. And that's going to give us k is greater than, because we had to flip our symbol because we divided by a negative, positive 4.5. Okay, so that's the first part of our inequality. Then we have this one. So these are both divisible by 3, so I'm going to go ahead and distribute the 1/3 because it's not too hard on this one. So 1/3 of 15 is 5, so we'll have 5k, and 1/3 of 9 is 3. So we have 5k minus 3 is less than or equal to -3. The other option you could have done would be to multiply both sides by 3, and that would cancel this, and you'd have a -9 over here. But I'm not going to do it that way. So we want to add 3 to both sides, and we have 5k. That equals 0. That also equals 0, but that's okay. We're just going to have 5k is less than or equal to 0. That's still a valid answer. And then we'll divide both sides by 5. I'm going to move this over. So we have 5k is less than or equal to 0. Divide both sides by 5, and 0 divided by 5 is 0. So we're going to get k is less than or equal to 0. And this is an OR inequality. So first we have k is greater than 4.5. So let's find positive 4.5. That's right here. And it's an open dot because it is greater than, not equal to. And since it's greater than, we go towards the numbers that are bigger than 4.5. Okay, then we have k is less than or equal to 0. So our dot goes at 0. Since it can equal 0, we color it in. And then it's less than or equal to 0, so we highlight all the numbers that are less than 0. All right, now let's write interval notation. The leftmost part is an arrow, so we have parentheses, negative infinity. Then we have a closed dot at 0, that means bracket. Then we have our gap, that means we need a union symbol. Then we have an open dot, that means parentheses, and it's at 4.5. And then we have our positive infinity arrow. So that's our answer to number 5. Let's go ahead and continue into the other type of inequalities, which are going to be and inequalities. And inequalities look like this. They have an end on both, they have a point on both ends instead of arrows. Okay, so this says that x is greater than or equal to -2 and less than +5. Okay, it has to satisfy both of those requirements. So the way that we're going to write this is we're going to look at the left number and the right number. This is -2 and this is +5. And I'm going to write that, I'm so sorry, my brain is completely tired right now. So our line goes between these two. So these numbers that the line goes through are bigger than -2, but they can also be equal to -2. So x has to be greater than or equal to -2, but it also has to be less than, but not equal to 5. Okay, it has to satisfy both of those conditions. And then for interval notation, if you look at our graph, remember I like to use the graph to do interval notation because you can just read it from left to right. The first thing on our graph is a closed dot, so a bracket at -2. And then we have an open dot at +5. And that's it. So it's the interval from -2 to 5, and it includes the number -2. But there's one other thing about and inequalities. We can rewrite these. We can condense them. So instead of writing it like this, x is greater than or equal to 2 and x is less than 5, what we're going to do is we're going to put the smallest number first, and then an x, and then the biggest number. And now if you look at your signs, the alligator is eating the x whenever it's between the two, or between the x and the 2, and the alligator is eating the 5 when it's between the x and the 5. And this is how your signs are always going to point whenever you write it in condensed form. So this says 2 is less than or equal to x, and x is less than 5. Okay? And you can also, that's not what I'm trying to say. I'm so sorry. To start this, like to try to learn how to condense these, what you can do is you put the variable in the middle, and then you put the numbers in order. The smallest one goes over here, and the biggest one goes over here. And this, your inequalities are always going to point this way. So it's going to be this is less than this is less than this. But then you have to look and see where you have to put equal symbols, because that all depends on your inequality. So in this one, the 2 gets an equal symbol, but the 5 does not. So we would just put that in there. Okay, so we're going to practice this. You'll get used to it. Not a big deal. Okay, so if the and inequality is written out, solve each part separately. If it's condensed, you can solve it all together working inside out. Then graph to show all possible solutions. So this one is separated just like the or inequalities were. So we're just going to solve them very similar to the or ones. So subtract 3, 2x is greater than negative 12. Divide both sides by 2, and we get x is greater than negative 6. So that's one part. And then over here, we're going to add 2, and we get 8x is less than 32. Divide both sides by 8, and we get x is less than 4. This is an and inequality. So just to show you how to rewrite these, this is not required of you. You don't have to condense it, but I just want you to get used to seeing what that looks like as well. Remember, we would put x in the middle, and you only use less than symbols whenever you do this. And then you put the smallest number on the left, so negative 6 is on the left, positive 4 is on the right. And then you look for equal to symbols, and neither of these have an equal to, so you're done. Okay? So this is correct, and this is correct. All right, so I'm going to get rid of all that so that we can just focus on the answer. All right, so we're graphing an and inequality. What I'm going to do is I know that x has to be between these two numbers. So negative 6 is going to get an open circle because it is not equal to negative 6. Positive 4 is going to get an open circle. And since this is an and inequality, we just connect those two dots. Okay? So that's pretty simple, right? So we have an open circle at negative 6 and an open circle at positive 4. So that is our interval. Easy enough. Let's try number 9. So number 9 is already in condensed form. So what I want you to do is kind of think of these as like equal signs, and we're just going to solve these equations at the same time. So A is in the middle, and you want A to be in the middle. You always want your variable to end up in the center part. So to get A alone, we're going to have to add 1. So we have to add 1 to all 3 parts of our inequality. So negative 2 plus 1 is negative 1, less than or equal to. Those are going to give me 0, so we just have A left. Less than or equal to 6 plus 1 is 7. So we're done. That's it. This is what we're going to graph. So whenever it is in this form, remember it has to be from least to greatest, okay? So negative 1 is on the left, positive 7 is on the right. That means we're in good shape to graph this and inequality. So it goes at negative 1, we have a greater than symbol. So we have to do a closed dot at negative 1. At positive 7, we also have a greater than symbol. So we have to have a closed dot at positive 7 as well. And then since it's an and inequality, we just connect those two dots. For interval notation, we have a closed dot, that means a bracket, at -1, and we have a closed dot at 7, so that means 2 brackets. Okay, not too bad, right? This is our very final example for and inequalities and for all of our compound inequalities. And it's another one that's already condensed. So again, this is the part where we want this to just have m. We want all the rest of this gone. So we are going to first add 2 to all 3 parts. So 28 plus 2 is 30, greater than. -2 plus 2 is 0, so that goes away. -10m is greater than or equal to -5. Now we need to divide this by -10 to get m by itself. And when we divide by a negative, we have to flip our signs. So this guy becomes less than, and this guy becomes less than or equal to. So 30 divided by -10 is -3. -10 over -10 equals 1, so that's just 1m. So we can just write m. And then -5 over -10 is positive 1/2. So this is the inequality that we're going to graph. Notice these are both less than signs, and this is smaller than this. And that means that we are all good to graph our and inequality. So first we have -3, and it gets an open circle. So at -3, we put an open circle. Then at 1/2, we put a closed circle. So here's 1, so 1/2 will be here. And since this is an and inequality, we just connect the 2 dots. So now interval notation, we get a parenthesis at -3, and then we get a bracket at positive 1/2. Thank you for watching this video. I hope that made this a little bit easier for you.